Alright, we're here at go-to-math.com. We had to pause at the pause. Volume disk method, no, I think there's 10 problems now. Let's click on that. What are we doing? Forgot, oh, we're revolving something. Whoa, find the volume of solid form by revolving about y equals 9. The heck? So we're not revolving around the x-axis. In other words, we're not going to take this and right? That'd be something funky. That'd be like a ring or something. Be a lot like a ring, wouldn't it? Anyway, let's write this stuff down. So hopefully you've watched some of the earlier ones, because I don't really go into, I start going into less and less detail and more on just working the problem out. The further we move on down the problem set, if you hadn't figured that out yet, but this should at least give you a basic idea of what we're doing. I work enough of these problems, and you should always come up with your own problems. Try to write up your own problems. Alright, so we got that. So this right here, if you can imagine, just take this whole thing and let's shift it all the way down to the x-axis. Right, draw a graph, shade it in just like this. Just take this thing, move it down here. Okay, to where this right here is actually the x-axis. So really that's all we're doing. So for some strange reason we got to move it up here and do this, we will. But see, we're revolving about this, so it's kind of like going here instead of down here at the x-axis. Alright, never mind. Let's go to the whiteboard. Let's write up everything they gave us. F of x, everything I say they gave us. I don't know, it's the script that gave it to us. It's all weird, man. We live in an alternative reality, let me tell you. Y equals 9. I mean, the world we live in is quite strange. And the world I lived in, let's say 15 years ago, maybe 20 years ago, I don't know. I mean, I would have never been able to help people out in Hong Kong, Russia, Philippines, you know. I mean, you name it, somebody has listened to my voice. All right, y equals 9. So remember how this goes. How does this go? Let's just sketch this out real quick. Sketch here. Yeah, I mean, I help people out all over the world for free. Right. It's pretty bizarre, to say the least. Still kind of freaks me out. This is 9 right here, right? So we're taking this thing and revolving it around. So basically what we're doing here is really, whether it's up here, over here, it doesn't matter. What's going really on here is the radius, right? The radius, this radius, we want to find this distance from here to here. And then we're summing up, if you can imagine, a bunch of little rectangles, summing them all up. Okay, so it's this minus this guy right here. That's all that it is, to find this distance right here. Going from, and actually this is 5 here, isn't it? So volume is equal to pi 0 to 5. Take the larger one up here, which is the square root of x plus 9 minus 9. Square it, right? This is going to be our radius times, remember the height of the cylinder, but we're just calling it dx now. Volume is equal to pi from 0 to 5. So those guys cancel out. And look at here, if they cancel out, then we're squaring a square root, so that's even nicer. That's just left with dx. When you square a square root goes away and you're left with x. Well, how convenient is that? Volume is equal to, so we end up with x squared over 2, going from 0 to 5. Right, so go ahead, plug this stuff in. 5 squared over 2 minus, and then we plug in the 0. Right, get 0. So this just becomes 25 over 2 pi. That's it. That's all there is. That's all we need to know. Right? That's it. What else is there? Let's do it. Hit the answer. That's it. There it is. 25 over 2 pi. Okay. So come on by, practice that. Practice. Practice makes perfect. We're here at gotomath.com. See you later.